Hello Gems! Welcome to the second episode of mock test series. This series is specially made for BITSAT and here we do a lot of grind for BITSAT. There's not a lot to say today, let the grind begin. So question 1 and 2 over here, let's get to it. In question 1 we have a square shaped current loop of side length L. Okay, it is carrying a current and it is placed in a uniform magnetic field. The direction of the field is perpendicular to the plane of your square loop and it is into the plane. Okay, so you are supposed to find what is the net force on the loop. So some of you might directly know it as a fact that the net force on a current carrying loop placed in a uniform magnetic field is 0. Okay, so option C, 0 is the correct choice over here. Let me justify it for those who don't know this as a fact. Okay, so here we have the square loop. Okay, it is carrying a current I. Okay, now if you see the magnetic field in this question is in the inward direction, we'll just calculate the force on the opposite two sides of this square loop. Okay, so first on this side, okay, on this side we'll try. Okay, so a force is given as IL cross B. Okay, so let's find the direction of force IL cross B. Okay, so L is along the direction of your current. Okay, direction of current, the length vector, and B is inward, right? So L is upward and B is inward. L is upward, B is inward. So L cross B, the forces in this direction. Okay, now if you see on this side, okay, so let's see on that side, L cross B. Okay, forces L cross B. So L is along the current vector again and B is inward. Okay, so L and B. Okay, L is along the current, okay, and B is inward. So again the forces outward. Okay, so if you see these two forces are equal, force equals ILB, I is same for both, L is same for both, length is same, it's a square, and B, magnetic field is uniform, right? So magnitude wise these forces are the same, but they are acting in two opposite directions. That is why these two forces are cancelling out each other and the net force on the square loop is 0. Okay, or you can also check it for the other two sides. Similarly, the forces will be outward or inward, maybe no, it will be outward, and they will cancel out and you'll see that the net force on the loop is 0. Or you may remember it as a fact that the net force on a current carrying loop placed in a uniform magnetic field is 0. Okay, let's come to question number 2 over here. Two parallel conductors which carry current in opposite directions. As you can see, this is carrying current in the downward direction. This here in this conductor we have current in the upward direction. Okay, that current is 10 amperes. Okay, and this wire is at a distance of d by 2 from a point C. Okay, now the distance d between the two wires is given as 18 centimeters, so this is 9 centimeters. Okay, and I is so adjusted, so the value of this I is adjusted so that the magnetic field at point C becomes 0. Okay, so what is happening over here is that, see, the magnetic field due to this wire is inward, right? The magnetic field due to this wire at point C is inward. Now the magnetic field due to this wire, okay, this wire is outward. Okay, is outward at point C, right? It is coming towards you, it is outward. So these two fields are cancelling out each other, and that is why the magnetic field at point C is becoming 0. I is adjusted in such a manner that these two fields cancel out each other. Okay, so that is the concept over here. We are supposed to equate these two fields. Okay, of course they are opposite in direction and equal in magnitude. Okay, that's why they are cancelling and the net field is 0. Okay, so field due to this wire, now it's obvious that the current in this wire will be of course greater than 10. Why so? Because this wire, if you see, the second wire is far away from point C. Okay, it has to cancel the field due to this wire which is closer to the point C, of course, so the current will be greater than 10. Okay, so you can eliminate certain options like 8 and 10. Okay, we have to select among the other two options, but let's solve it. So magnetic field due to wire 1, we'll call this wire 1, mu 0 upon 2 pi I1 by R1. So I1 in this case is the current I which it is carrying, and R1 is the distance d plus d by 2, distance from point C, which is 3d by 2. Okay, and B2 is the magnetic field due to this wire, which is again mu 0 upon 2 pi I by the distance I over here is 10, right? So I'll just substitute 10, and the distance is d by 2. Okay, d by 2. Okay, this and this will get cancelled, so I will be this is 3d by 2, d by 2 can also get cancelled, and I will be nothing but 3 times of 10, which is 30 amperes. So option B, 30 amperes greater than 10, obviously is the correct choice over here. Okay, I hope that was simple to understand. Let's move to next set of questions now. So question 3 and 4 over here, let's do it quickly. In question 3, we are asked for the number of photoelectrons in photoelectric experiment depends on. Okay, it's a simple question. The number of photoelectrons merely depends on the intensity of the light, right? The frequency of the light used will determine the kinetic energy of the electrons, whereas the intensity will determine the number of photoelectrons. Or take it this way, that more the number of photons, or basically more intensity means more brightness. More brightness is due to more photons or more photon density. So more the number of photons, more will be the number of photoelectrons emitted. Okay, so yes, intensity of the light used is what influences the photoelectrons. Okay, now let's come to question number 4. In this, we have a hydrogen atom, and we are told that lambda 1, lambda 2, lambda 3 are respectively the shortest wavelength of Lyman, Balmer and Paschen series. You are supposed to tell what is the ratio between them. Okay, so again some decoding is required. Shortest wavelength, if you see, corresponds to longest energy transition. Okay, basically energy is inversely proportional to lambda, right? So shortest wavelength means highest energy. Okay, so basically the largest energy transition. Okay, why am I speaking of this? So first of all, let us write it for Lyman series. Okay, so for Lyman we have the shortest wavelength as lambda 1. So 1 upon lambda 1, I hope you know this formula. It is R into 1 minus n final square minus n initial square. Okay, so I'll write it generally first. Now let's write it for Lyman series. So shortest wavelength is lambda 1. Okay, so just now I told you that energy is inversely proportional, and shortest wavelength means highest, biggest energy transition. Okay, so n final in case of Lyman series is always 1. Okay, so finally it comes down to 1. So 1 square 1, and finally n initial in all these cases will be infinity. Okay, so basically that is the longest energy transition or the shortest wavelength. Okay, so infinity square again, so this term is 0, and we have 1 upon lambda 1 as r, or lambda 1 as 1 by r. Okay, so similarly if we calculate 1 upon lambda 2, it will be r, and again finally in Balmer series n final is 2. Okay, so after all the transition it comes down to 2. So 2 square 4, and final square, which is 2 square 4, and again infinity square, that will be again 0. So we are left with this, right? So this is for lambda 2. So lambda 2 is 4 by r. Okay, so you can see it where this is going. So 1 is to 4 is to 9. Next is 9. Yes, of course. So 1 upon lambda 3 is r 1 minus n final square, Lyman, Balmer, Paschen. Yes, 3. So 3, then n final square, that is 9. And again 1 minus infinity square, that is 0. So we are left with this. So lambda 3 is 9 by r. Okay. So 1 is to 4 is to 9. 1 is to 4 is to 9. Option A is the correct choice over here. I think this was one of the questions that we did in a series as well. Okay. Anyways, let's move to the next question now. So question 5 and 6 over here, let's get to it. In question 5, we are told that half-lives of A and B are 1 hour and 2 hours respectively. You are supposed to tell which is the correct statement among the following. Okay, so element A decays slower. Okay, so if we begin at the same concentration, suppose A and B. So if we begin at A0 and A0, okay, so it will take 1 hour for A to become A0 by 2. By the definition of half-life, it is the time that is required for the substance to fall to half of its initial concentration. Okay, concentration of the nuclei. So again for B, it will take 2 hours to become A0 by 2. So if you see, for A it just takes 1 hour to become half of its initial concentration. For B it takes 2 hours to become half of its initial concentration, which means that A is decaying faster, right? It becomes half in just 1 hour. This takes 2 hours to become half. Okay, so A is decaying faster, not slower. so option A is not correct. Then we have decay constant of A is smaller. Of course, A is decaying faster, so decay constant of A is bigger, not smaller. Okay, so again option B is incorrect. Now, if the initial concentration of nuclei is same, the activity of A is more. Okay, so yes, lambda A is more, so yes, activity of A will be more. This is correct. So if you just multiply n naught throughout, okay, so this is the initial concentration. Okay, so I've just multiplied n naught on both the sides. So this is the activity of A. R is basically lambda times of n, right? R naught is lambda times of n naught. So this is the initial activity of A. It is greater than the activity of B. Okay, so option C, the activity of A is greater than the activity of B. And mean life, again, now option C is correct, so of course option D will be incorrect, but let's just verify it. Okay, so mean life of A is more. Half life and mean life, by the way, are directly proportional, right? So mean life of A is more, mean life of B will be more. The higher, the one that has higher half life will have higher mean life, okay, or more mean life. So option D is again incorrect. The mean life of B will be more. Okay, let's come to question number 6 now. A glass piece which is immersed in a liquid, okay, the refractive index of the liquid is given, the glass piece disappears. You are supposed to tell what is the refractive index of the glass piece. Now it's a little bit conceptual, okay. So here actually this is a project that you can do. I'll put a picture up over here that may help you guess some things, okay. So the thing is, if you have the refractive index of the material and the liquid same, the material when immersed in that liquid will disappear. Okay, I'll convince you about that. So if we have a liquid like this and if we have this glass piece, okay, so if they have the same refractive index, the light will pass through this without bending, okay, without bending or reflecting, or the basically the speed of light will not change when it passes from this liquid to that glass piece, right? So the light will not bend, it will not reflect or refract. Okay, so you cannot see the boundaries. Okay, so light just passes through it, does not reflect or refract, so you cannot see the boundaries of that piece separately. Okay, so yes, when the refractive index of the glass piece is equal to the refractive index of your liquid, you will not be able to see it. So option B, the refractive index of the glass should be 4/3, same as the liquid, in order for it to disappear. Okay, I think that was a bit simple. Let's move to the next question now. So question 7 and 8 over here. In question 7, we have a biconvex lens. It is cut as shown in the figure. So we are going to cut it this way and then we'll obtain a piece like this. Okay, we are supposed to tell what will be the focal length of this piece. Okay, it's not that difficult. Just follow up. So here we'll apply the lens maker formula twice. So first we'll say 1 upon f, which is the focal length of this lens. Okay, the original lens. So that will be mu minus 1. Okay, so mu is the refractive index of the lens and surrounding will consider it as air. So mu minus 1 into 1 upon r1 minus 1 upon r2, right? So r1 is for when the ray strikes this. Okay, this is the first surface, so r1 is plus r. Okay, so we'll consider it as plus r, and r2, if you see, the ray strikes second on this surface. Okay, the second surface, so this is r2. Okay, so this is r2 and it is going in the direction opposite to that of the incident ray, so it is minus r. Okay, so minus r will become plus r. Okay, so I hope you are able to follow that. So 1 upon f is mu minus 1 into 2 by r. Okay, so 1 by r is 2 by r. Finally, we have for this mirror also will apply lens maker formula. So 1 upon f dash, mu will not change, refractive index of course will not change when you cut the mirror. So here we'll have 1 upon r1. Now r1 is this. Okay, again it's r, the same, right? So this side is the same. Okay, this is the same convex edge. Okay, so yes, it has the radius r. Okay, so 1 upon r, and that is plus in the direction of the incident ray, and minus the other surface is this one, right? The second surface is this is a plane surface, and it is, if you see, the radius of the plane surface is infinity, right? So here 1 upon infinity, that is 0. So 1 upon f dash is mu minus 1 into r, right? So you can actually take the ratio of this two, or you can just compare. You'll see that this, if I write it this way, 1 upon r into 2, so this is nothing but 1 upon f dash, right? So this is, I'll do it over here, so 1 upon f is equal to, this is nothing but 1 upon f dash, and this is into times 2. Okay, so what can I do? So I want f dash, right? So f dash will be 2 times of f. Okay, so the correct answer over here is option A. F dash is 2 times of f. Okay, so some of you might directly know it, that when you cut a biconvex lens vertically, the focal length becomes twice of the initial. Okay, so f dash will be 2 times the original focal length. Okay, and if you cut it horizontally, the focal length will not change. Okay, so that's just a fact. Let's come to question number 8. Refractive index depends on. Okay, now this is again a very conceptual question. The option which says medium only is quite tempting, right? A refractive index is like a property of a material, then I think only it should only depend on the medium, and here is the tricky part. Okay, it also depends on the light which is incident on it. Okay, I can explain you on the basis of dispersion. Okay, why does dispersion happen? Because different colors have different wavelength, and for different wavelength the refractive index is different. That's why they split up at different angles of deviation and the colors are separated. Okay, we have a spectrum over there. Okay, so refractive index is different for different wavelength, which means that refractive index depends on the material as well as it depends on the incident light. It depends on the wavelength of the incident light. Okay, so it depends on both, not just the medium. Okay, so option C, both, is the correct choice over here. How will you remember it? Remember dispersion. Okay, that is the best example that I can give over here. So let's move to the next set of questions now. So question 9 and 10 over here. In question 9, we have a uniform shell of mass m. We are supposed to tell what will be the work done to take a point mass from point A to B. Point A to B, the distance between the 2 points is less than the radius. Okay, so basically you are moving the test mass inside the spherical shell, and as you might know, inside a spherical shell the gravitational field is zero, just like it's analogous to electrostatic. Okay, so just like the electric field inside a spherical shell is zero, the gravitational field inside a spherical shell is zero. Okay, so basically if the field is zero, what will you work against? Okay, so there is no field to work against, and hence your work done will be nothing but zero. Or take it this way, that the work done will be basically the test mass into the change in potential, gravitational potential. Okay, mass into gravitational potential. If you remember the electrostatics potential, the work is given as q into delta v. Here q is replaced by the test mass, test charge replaced by test mass. Okay, and inside the spherical shell, since the field is zero, the gradient of the field, which is potential is constant. Okay, so inside the spherical shell potential is constant, so delta v is 0 because v is constant. Okay, so delta v is 0, which means work done to move the charge inside the spherical shell will be 0. Okay, quite a conceptual question over here. Let's come to this one. A body of mass, this is attached to a spring. Okay, this is the natural length of the spring, this is the spring constant, and it is revolved with this frequency. Okay, 30 revolutions per minute or half revolutions per second. So you are supposed to tell what is the radius of this circular motion. You are also supposed to tell what will be the tension in the string. Okay, so first of all, it's not a string, it's spring. So we have a spring. Okay, we are going to rotate a mass. Okay, so there will be some centripetal force, or if we go into the frame of that, there will be some centrifugal force. I'll call it mv square by r. Okay, this is a pseudo force to your centripetal force. Okay, and we have force over here, which is the spring force. Okay, this is the spring force. This two forces will balance each other and your object will move in a circular motion. Okay, and this will be natural length plus some delta x of your extension. Because of this force, your spring will be extended a bit. Okay, so you are supposed to find the radius of this circular motion, which is L plus this extension, the natural length plus some extension due to that outward force, okay, due to that centrifugal force. Okay, so first of all we have to find this delta x. How will we find that? Okay, so we can actually equate these two forces. Okay, so mv square by r will be equal to your spring force, which is k times delta x. From here you can easily find delta x, right? So mv square by r, I'll write it in the form of omega. Okay, m omega square by r, v equals r omega. That is the relation that I'm using, v equals r omega. So if you substitute, you'll get like this. So this is k times of delta x. Okay, because everything is given in the terms of angular frequency. Okay, so yes, frequency is given, so we can find angular frequency. Okay, so angular frequency will be basically 2 pi f, right? 2 pi nu, so that will be 2 pi, and nu is 30 revolutions per minute. So divide by 60, that is half. 30 by 60 is half, and that half will cancel with this. So omega is nothing but pi radians per second. Okay, k is 2, yes. So delta x will be m, the mass of the body is 20 grams, so 20 into 10 to the power minus 3 into pi into r. R is what? R is the radius of your what can I say, radius of the circular motion. Okay, so it is L plus delta x, natural length plus that extension. Okay, and this is squared, right? So when you solve this, okay, you can see that everything is given. K is also there, right? Divide by k, k is 2. Okay, L is given, L is the natural length, which is 50. So when you solve this, only unknown is delta x, right? So when you solve this, you'll get the value of delta x. It's just calculation now, so I'll leave it there. So delta x value, you'll get it as 0.05 meters. Okay, now what is your radius? Your radius is L plus delta x. Okay, remember that. So L plus delta x, L is 50 centimeters, or you can convert that to meters, that will be 0.5 meters, plus this, which is delta x, 0.05, that is 0.55 meters. Okay, so here we have 0.55 meters, and that should be the correct answer. We'll also find the tension in the spring. Tension basically means the spring force over here. Okay, so spring force is nothing but k delta x, right? So k is 2, and delta x, the extension is 0.05. Okay, so 5 2s are 10, that will be 0.1 newtons. So yes, option C is the correct choice over here. Okay, I hope this was simple to understand. Let's move to the next question now. So question 11 and 12 over here. In question 11, we have a gramophone record, the old kind of record stuff, and then it has a mass m and a radius r. So that is a disc of mass m and radius r. It is rotating at an angular velocity omega. Now you'll gently place a coin on that gramophone record. Okay, so a coin has a mass m. Okay, and it is gently placed on that record. Okay, so it is placed at a distance r by 2 from the center. Okay, so it is placed at half the distance of the radius. Okay, you are supposed to tell the new angular velocity. Of course, when you place the coin, what will happen? The angular velocity will fall down. Okay, the record is going to slow down. Eminem will become Ed Sheeran, whatever. So yes, so basically the record will slow down. Okay, so basically when it's spinning fast, initially omega, the new omega will be lesser. Okay, and you get a clue over here. The coin is placed gently. Okay, so here we are supposed to apply the conservation of angular momentum. Okay, so basically gently means no external torque was applied. Okay, so I1 omega 1, so basically that is the thing that we are supposed to do. I1 omega 1 is equal to I2 omega 2. I1 is when the record is revolving by its own and has a velocity omega. So I1, it is a disc, right? A gramophone record is a disc of mass m and radius r, so half m r square. This is the moment of inertia for a disc. Okay, now I2 is we have the record again revolving, and we also have a coin. Okay, a coin which is placed at a distance r by 2. Okay, so yes, we have both of those things. So first of all, we have the disk, so again half mr square, and we also have a coin. Okay, now this coin is at a distance r by 2 from the axis. Now we can treat this coin as a point mass. Okay, its radius is not given, it's not that significant, it's just a point mass. Okay, and it has a mass small m, I guess. Yes, it has a mass small m. So m, and what is the distance? R by 2, m r by 2 square. Okay, m r square, right, for a point mass. So m r by 2 the whole square, and this into omega dash, I'll say. This is the angular velocity, the new angular velocity that we are supposed to find. Okay, so what can cancel first of all? So I think r square can get cancelled, so half m r square will cancel throughout. If you see, we have omega over here, and we'll have half m plus m by 4, right, and this into omega dash. So omega dash will be nothing but half m omega by, so actually I can first, what I'll do is I'll take the LCM 4, and this will be m plus 2m plus m. Yes, now you can see the answer actually over here. So it will be 2m, yes, plus m, and this is going to cancel. I'll show you m omega. So half, and this will cancel. So we'll have omega dash as 2m, 2 omega m, right, 2 omega m upon 2m plus m into this omega. Okay, yeah, we have this. Okay, so this is option A. So option A is the correct choice over here. It's quite simple. I1 omega 1 equals I2 omega 2. This is only for the record. This is for the record plus the coin. Okay, now let's come to this one. A man runs at this speed. He wants to overtake a bus which is at a distance of 6 meters, okay, from him when he first begins at time t is equal to 0. So the bus moves with a constant acceleration of this. Okay, you are supposed to tell when will the man reach the door. Okay, or you are supposed to frame the equation when the man reaches the door at time t. Okay, you are not supposed to solve that equation in order to tell the time. You are supposed to just tell the equation. Okay, so first of all, let's picture the scenario. We have the man over here at a distance of 6 meters from the bus. The bus is moving with an acceleration of 1.6 meters per second square. Okay, its initial velocity of 0 was 0 at time t is equal to 0. When at t is equal to 0 began with a velocity of 4 meters per second, right, towards the bus. Okay, of course he wants to overtake, right, so it's towards the bus, right. Now you can actually solve it in two different ways. You can actually take time t and consider the motion of bus and the motion of men and then make them meet. Okay, or else you can apply relative motion. Okay, so relative motion is the best, I guess, so I'll use relative motion. So I'll bring the bus at rest. So this is 6 meters. So bus, I'll give the acceleration of bus, flip and give it to the man, right. So that is the concept of your relative motion. Okay, so now the bus is at rest and the acceleration of the bus is flipped and given to the man. Okay, so now we are just supposed to solve this. When will the man cover a distance of 6 meters? So for that I can use s is equal to ut plus half at square. Okay, so s, the distance he wants to cover is 6 meters. U, initial velocity of the man at time t is equal to 0, the velocity is 4. So 4 times of t, okay, 4 times of t plus half, acceleration is minus 1.6. This direction is considered as positive, this is negative. So minus 6 and t square. Okay, fine, t square. So this and this will get cancelled, and I think acceleration is 1.6, sorry, 1.6. So half of that is 0.6. So 0.6 t square, that is minus. You'll bring it to this side, so that will become 6 plus 0.6 t square, and on the right hand side you'll have 4t. So 4t equals 6 plus 0.6 times of t square. If you solve this equation, how? Quadratic formula, okay, or by factorization maybe, I don't know. So if you solve that equation, you'll get the time at which this bus and the man meets. Okay, so that is all from this question. Let's move to the next question now. So question 13 and 14 over here. In question 13, we have a block of mass 1 kg. So let's simultaneously draw it. So we have a block P of mass 1 kg. Beneath that, we have a plank Q. Okay. So both of these are placed on a smooth horizontal surface. There is friction between block and plank, but there is no friction between the plank and the surface. Okay. Now this block P is given some velocity 2 meters per second to its right. Okay, you are supposed to tell what is the acceleration of Q relative to P. It is also given that the coefficient of friction between Q and P is 0.3. Okay, so first let us study the motion of block P. Okay, block P, if you see, we have given it some velocity 2 meters per second, and if you see, there is relative motion happening over here, right? Block P will slide over block Q. It is moving in the forward direction, so friction will oppose this relative motion. Friction will pull it back. Okay, so here we will have frictional force. Okay, so we can apply F net equals ma over here. Okay, that is what we are going to do in both the cases. We'll study block P, block Q, F net equals ma. From there we'll get acceleration of P, acceleration of Q, and then we can find relative acceleration, right? So F net equals ma. So if you see, the only force that is acting on this block is the frictional force. This is velocity. This is the only force that is acting on it. So we have the frictional force equals m times of acceleration of P. Okay, so frictional force is nothing but mu n, and n in this case will be nothing but mg, right? The mass of the your P. Okay, mg I'll say. So n is nothing but mg. Okay, here also it is small m. Okay, so m and acceleration of P. So m and m will get cancelled. Okay, anyways they are 1 each. Okay, so mu g, mu is 0.3 and g will take it as 10, so 30, 0.3 and 10, that is 3. Okay, so 3 meters per second square is the acceleration of P. Now mind you, this acceleration is in this direction. Okay, it's in negative direction. We'll consider the forward direction as positive and this direction as negative. We are supposed to find the relative acceleration, so there we'll need the directions. Okay, so this acceleration is in the negative direction. Now let us study the plank Q. Plank Q, if you see, the block P is sliding on plank Q. Okay, so it's sliding forward, so there is relative motion over there and block Q is being left behind. Okay, so what will friction do? Friction will pull it in front in order to oppose relative motion, because block P is moving in front and block Q is left behind, so the friction will pull it in front. So in a way to oppose relative motion, or you can imagine it this way, that your Newton's third law, for every action there is equal and opposite reaction. So this force, frictional force, is in the backward direction. So for block P, equal but opposite, so frictional force will be in the forward direction. Okay, of course the two forces act on two different bodies, right? So equal and opposite forces acting on two different bodies. Okay, so equal force F but opposite in direction. Okay, so now the only force acting on block P is your frictional force, and that equals m into acceleration of Q. F net equals ma. So frictional force, again mu n, the same value, basically it is mu n. Okay, mu n 0.3 into 10, and also the mass. Okay, so that is 1 anyways, so 0.3 into 10, that is 3 newtons. Okay, and then we have the mass of mass of Q over here, which is 6, and acceleration of Q, which we are supposed to find. So acceleration of Q will be nothing but, this is 3 newtons. Okay, so 3 divided by 6, which is 0.5, and this is in the positive direction, right? It's in the forward direction. Friction is pulling it forwards. Okay, so basically you are supposed to find acceleration of Q relative to P, which means acceleration of Q minus acceleration of P. This is the formula for relative motion. Okay, so acceleration of Q, which is 0.5, and acceleration of P, which is minus 3. Keep it with the sign. Okay, so that will become plus 3. So the answer is 3.5 meters per second square, which is option B. Okay, 3.5 meters per second square. So study their motion separately. F net equals ma, acceleration from both of those formulae. Okay, and then substitute it in the relative acceleration formula. Okay, finally let's come to this in completely inelastic collision. I think we also did it in the previous mock test. Excuse me. Okay, so here complete kinetic energy of the system is lost. Is it true? No. Okay, here in this case, please remember that in any type of collision, the linear momentum is always conserved. Okay, so option B is the correct choice over here. Okay, any type of collision, inelastic, elastic, oblique, whatever, the linear momentum of the system is always conserved, or momentum as a whole of the system is always conserved. Okay, so option B is the correct choice over here. Complete kinetic energy is not lost even if the collision is inelastic. There is some deforming, some amount of kinetic energy is lost, but not complete amount of it is lost. Okay, so yes, option A is incorrect. C is also incorrect. So due to that reasons, these two are also incorrect. And then linear momentum, of course, stays conserved in any type of collision. Okay, so that's a point to remember. But let us move to the next set of questions. So question 15 and 16 over here, almost halfway there. Okay, so question 15 is based on dimensional analysis. You can see a formula over here. Here n, this n stands for the number of particles that cross a unit area in unit time. Okay, n1 and n2 are the number of particles per unit volume. Okay, and x1, x2 denote the positions in meter. So basically they are lengths. Okay, so their unit is meter, so they stand for length. Okay, then the dimensional formula for the diffusion constant d. Okay, so I can write it this way: n equals d. I'll write this as delta n, and I'll write this as delta x. Okay, so that makes it simple. So we have n times delta x divided by delta n. Okay, or I'll use n dash because we have n in the formula. Okay, now this n is for number of particles crossing a unit area in unit time. Okay, so number of particles dimensionally, that does not have any dimension. It's a number, right? So number of particles, then we have per unit area and unit time. Okay, so that will have dimensions of per unit area, that is L square, so 1 by L square, and per unit, right? So per unit area and per unit time, so unit time. Okay, so these are the dimensions of n. Okay, then delta x is basically the positions, right? X2 minus x1 will be something in meters, right? So that will be length. Okay, so delta x has the dimensional formula of length. Okay, then delta n is the number of particles per unit volume. So number of particles, that is again just a number, divided by volume. Volume is 1 by L cube, right? So per unit volume, right? So 1 by L cube. Okay, so what can cancel over here? Okay, so if you see L square, okay, so I can cancel actually this, all of this will get cancelled, L square will cancel, and I'll have one L that will go on top. So L and L square it will become, right? So L square and t raised to minus 1. L square t raised to minus 1. This will become L square and t on top, t raised to minus 1. L square t raised to minus 1. Where is that? Option D. Okay, let me just check that. Okay, so yes, that is correct. L square t raised to minus 1. Okay, let's come to question number 16. Now in this question we have a circuit over here. Okay, and it is told that after some time, okay, the capacitors will get charged. You are supposed to tell what will be the charge on each capacitor. All the capacitors are identical, which means that they have the same capacity, and it is given as 3 microfarad. Okay, you are supposed to tell what will be the charge on each capacitor. Okay, so first of all, when all the capacitor gets charged, okay, there will be no current in this branch, right? The capacitor will store the charge, and this will just act like a open circuit. This will also act like a open circuit. You might remember that when a capacitor is fully charged in steady state, I guess they call it. So in that state, there will be no flow of current in that branch where there is a capacitor. Okay, so this will just act like a open circuit. So we have a simple circuit over here, as you can see. Okay, this is a simple circuit over here, right? So we just have two resistors in series. They are in series, by the way, because same current is passing through both of them. So we have 4 ohm and 1 ohm in series, and we have a 10 volt. So we can find the current in this circuit. I is equal to V by R, right? So V is 10 volts and the effective resistance is 4 plus 1. They are in series, same current passes through both. Okay, so 4 plus 1, 5, and that is 2 amperes. So 2 amperes is the current that is coming from this circuit. So my objective over here is to find potential difference at these 2 points. Okay, that will be the same potential difference across these 2 points, right? So that potential difference I'll split among these 2 capacitors. I'll make it half because capacity is the same, and then I'll use Q is equal to CV, right? So my objective over here is to find potential difference, okay? And then I can use Q is equal to CV. C is given, V is something that I'm finding, okay? So what will be the V over here? V will be basically I into R. I is 2 amperes and the resistance over here is 4 amperes. 2 4s are 8, so 8 volts. So I have to divide this 8 volts among 2 capacitors, right? And current is not flowing, so this resistor is good for nothing. Okay, so there is no voltage drop across this. Okay, so here I have to split the current among the potential among these 2 capacitors, and it will split equally. So each capacitor will get 4 volts. Okay, so each capacitor will get 4 volts and 4 volts. Okay, basically because they have the same capacity, so the charge will be the same and also the potential will be the same. Okay, so Q is equal to CV, and C is 3 microfarad, and into 4, that is 12 micro. I think the charge should be in coulomb, so 12 micro coulomb. All of this was in coulomb. Okay, so option C, 12 microcoulomb is the correct choice over here. Let's move to the next question now. So question 17 and 18 over here. In question 17, we have placed a solid conductor in an electric field. Okay, you are supposed to guess what will be the path of the lines of force. Lines of force basically mean electric field. It's a very old word for it. Okay, anyways, let's discuss about this now. So we have a solid conductor. So here you are supposed to know just 2 things. One is that first of all, electric field lines don't pass through the conductor. First of all, there is no electric field inside a conductor. Okay, and second, the electric field lines are perpendicular to the surface of the conductor. Okay, so knowing these 2 points, you'll be able to solve this. So here, if you see, the electric field lines are going through the conductor. This is incorrect. It's going okay, it's not going through the conductor. Okay, but here it is perpendicular to the surface, but here it is not perpendicular to the surface, right? Here if you see, yes, this is correct, right? It is not going through the conductor. Okay, inside the conductor the electric field is 0, and it's perpendicular to the surface, right? Here it is perpendicular, and here also to the incline it's also perpendicular. Okay, so option C is correct. Again, here it's passing through, so option D is incorrect. Now let's come to question number 8. So a bomb at rest explodes just like that, and it explodes in 3 parts of same mass. The linear momenta of 2 parts is minus 2 pi cap and this. Okay, and the third part, the linear momentum, is this. This is the magnitude of the linear momentum of the third part. You are supposed to guess what is the x over here. Okay, so let's imagine this. So we have a bomb. We don't have actually. This will explode into 3 equal parts. Okay, so first among them will move in this direction with a linear momenta, thus 2p I cap. Okay, so assume that this is 2p. Okay, and this is minus I cap direction. That's why I drew it like that. Now the other one will go in the j cap direction. Okay, and it is p j cap. Okay, now the third one will be actually, if you see here, the bomb was at rest initially, and the forces were internal, right? The explosion is due to internal forces. There was no external force, so the momentum should be conserved. So that means final momentum should be 0. Okay, so the resultant momentum of this 2 will be cancelled by the third part. Okay, so we have the resultant momentum of this 2 in this direction. Okay, by parallelogram law. Okay, so our momentum of the third part will be along this direction. Okay, so that it cancels this momentum. Finally, So final momentum equals initial momentum, or we can cancel the horizontal and the vertical component separately. Okay, so the horizontal component of this momentum, which is along this, will cancel the horizontal component, and the vertical component will cancel the vertical component. Okay, it's as simple as that. So horizontal component will be 2p I cap. Okay, same magnitude, opposite direction, and this will be the vertical magnitude will be p only, but the direction will be minus j cap. Yes. So now we have the P3. P3 is nothing but this is the third momentum of the third part, right? So it is 2p I cap minus pj cap. Okay, so this is, I have written that in vector form. Now just find the magnitude. This is the magnitude of your third part. Okay, so magnitude is basically given as under root of this square plus this square, right? So 2p square, which is 4p square, plus p square, right? So that is 5p square. P square will come out as p and we'll have under root 5. Okay, so that x is nothing but option B, 5. Okay, I hope that was simple. So the idea that we used over here is conservation of linear momentum. Okay, let's move to the next question now. So question number 19 and 20 over here. In question 19, you are asked for the nature of pseudo force. Okay, is it an electromagnetic force, nuclear force, gravitational force, or none of the above? Okay, so if you see, pseudo force is a fake force, right? It is something that we bring up when the frame is non-inertial. Okay, so it is a kind of a fake force and it does not really exist. If it does not really exist, how can you tell its nature? Okay, so due to that reason, it is none of the above. Okay, it is a fake force, it does not really exist, so how will you tell its nature? Okay, so yes, option D is the correct choice over here. So behind every non-inertial motion there is a pseudo force that does not exist. That's a meme. Okay, anyways, so let's come to this. Here we have an inclined plane. Okay, we have placed a block on a smooth inclined plane. Okay, now we'll give this inclined plane some acceleration a0, which is equal to g in this direction. So when you give this acceleration, the block will move up. You can imagine that when you give that acceleration, the block will move up, right? The inclined plane will push into the block and the block will move up. Yeah, that's easy to imagine. Now this AC length is 1 meters. You are supposed to tell the time taken by this block to reach from C to A. Okay, so initially the block is over here, it will reach to A. Okay, this distance is 1 meters. Okay, so what is the time taken? So first of all, let us draw the free body diagram of that. So along the incline, we'll have mg sine theta, sine 30. Okay, so I'll write it as sine theta only. And here perpendicular to the incline. So this is mg sine theta and mg cos theta. I hope you know how to draw the free body diagram. So along the incline, it's mg sine theta, perpendicular to the incline is mg cos theta. Okay, and here we'll have the normal force N. Okay, and also if you see, this is a non-inertial frame, right? We have an acceleration over here given to the system. So here we can actually go into the frame of the block and we can use the concept of pseudo force, just now what we discussed. Okay, so we'll jump into the block system. Okay, I'll go on the block and I'll apply this force, right? I'll give this acceleration to the block, I'll flip and give this acceleration to the block. So it will look somewhat like this, ma0. Okay, so I flipped this acceleration and gave it to block. This is the pseudo force, the force that does not really exist. Okay, so here we have ma0. Okay, now I can break that ma0 into two components. So actually what I'll do, first I'll draw a perpendicular like this I have drawn. Okay, so here the angle is actually theta. Actually here you get mg and then you break it into mg cos theta and mg sin theta. Okay, so this angle is also theta. Theta is nothing but your angle of incline. Okay, so this angle is also theta. So this angle will be, this total is 90. Okay, so this will be 90 minus theta. Add those two, you get 90. Okay, so this is theta, this is 90 minus theta. Now I'll break this ma0 into two components. So ma0 along this line I'll break. This is 90 minus theta. So adjacent to theta is adjacent to theta is cos theta. Okay, so ma0 cos theta. and it will be along this, okay. And here we'll have ma naught sine theta, horizontal component, sorry, ma naught cos, and the theta over here is 90 minus theta, right. And here we'll have ma naught sine 90 minus theta, okay. So here we'll have, so I've broken this into two components, ma naught cos 90 minus theta, which is along this, okay, and ma naught sine 90 minus theta, okay. Now this vertical forces will balance out each other, okay. There is no vertical motion, okay. So this forces, the normal force will balance this mg cos theta and this ma naught cos 90 minus theta, and these are the forces that are responsible for the motion, okay. So here sine 90 minus theta can be written as cos theta, right. So these are the forces in the horizontal direction that are responsible for the motion of block. So here I'll use F net equals ma, okay, F net equals ma. So F net, if you see the block is moving up, so this force is greater than that. So ma naught or mg, directly I'll write a naught is basically g. So mg cos theta minus, this is mg sin theta, so I can take mg common, so cos 30 minus sin 30, theta is 30, cos 30 is root 3 by 2, sin 30 is half, okay. So we have ma, m and m will get cancelled, g, so basically you'll have g by 2 into root 3 minus 1. This is the acceleration, okay. This is the acceleration of the block. This was my aim, to find the acceleration, and from here I can find the time. If you substitute the values, the acceleration will come out to be I guess 3.66. Please confirm that, okay. And then you can use s is equal to ut plus half at square, okay. This term is 0 because initially the block was at rest over here, okay. And finally, so you can find the time using this formula, okay. Time will be 2s, s is 1 meters, and divided by 3.66. I think option A is the correct choice over here. Yes, option A is the correct choice. When you solve this, you'll get option A. Okay, so that's from question 20. Let's move to the next question. Question number 21 and 22 over here. In 21, we have an equation and we are told that A and C have the same dimensions as that of capacitance and magnetic induction. Okay, so you are supposed to tell what is the dimensional formula of B. Okay, first of all, we can write that as A by C square. Dimensionally, we can write it as A by C square is equal to B. Okay, the 3 is constant, so we don't worry about it. Okay, so dimensionally we can write it like this. So A has the same unit, same dimension as that of capacitance, and C has the same dimensional formula as that of magnetic induction or magnetic field. Okay, so first let us find out the dimension of capacitance and magnetic field. Okay, now for capacitance, what is the best formula to find dimensions? A epsilon naught by D? No, epsilon itself has some dimensions which we don't know. Okay, it is a dimensional constant. Okay, so what can be the best formula? For capacitance, we can actually use Q by V. Okay, yes, C is equal to Q by V. Q, if you see, they have used Q as a fundamental physical quantity, you can do that. Okay, instead of current, they have used Q as the fundamental quantity. Okay, so I'll keep it as Q only instead of AT. Okay, so this is Q, and you can write potential as V by Q. Okay, sorry, potential can be written as work per unit charge, right? So work is, okay, I'll write it as work per unit charge, so that will go on top and it will make Q square, right? Work by charge, so work by charge, so that will go on top and it will make this Q square. Okay, now work has the dimensional formula of mass into velocity square, right? It's just same as your kinetic energy. So yes, so we get the unit of capacitance. Now this is capacitance, not the C. I'll write it this, I'll directly write it as A. Okay, understand that this is the dimensional formula of A or capacitance. So you'll get M minus 1 L minus 2 T raised to 2 and Q raised to 2. Okay, this is the dimensional formula of capacitance. Now we have to find dimensional formula of C, which is magnetic field, magnetic induction or magnetic field. Now what is the best formula? Mu 0 upon 4 pi? No, that not that one, because mu 0 upon 4 pi is a dimensional constant and it has some dimensions, okay, which we don't know. We can use F equals QVB, Lorentz force, okay, and from here you can find the dimensions. F by QV will give you the dimensions of magnetic field, or here in our case it is the dimension of C, right? C, okay. So this will give us C equals F is mass into acceleration, so mass into acceleration, and Q is, again we'll keep Q as it is, and V is what? V is velocity, not voltage, so length into length per time. Okay, so this is Q. Okay, length and length will get cancelled, and here we get M t raised to minus 2. Okay, fine, and m t raised to minus 2. Okay, m, and it will be t raised to minus 1, right? And also we'll have q raised to minus 1. Okay, that is fine. So this is the dimensional formula of C. This is the dimensional formula of A. Let's substitute it over there and get the dimensional formula of B. Okay, so dimensional formula of A, which is m minus 1 L minus 2 t raised to 2 q raised to 2 upon C square, so square of this, so m square L, and there is no L, t raised to minus 2 q raised to minus 2. Okay, so easily you can see this will become m raised to minus 3, so this or this, L raised to minus 2, so this again, this or that, again t raised to 4, t raised to 4, t raised to 4, this one. So option D is correct, and q raised to 4, yes, option D is the correct choice over here. Okay, it's quite simple if you know the formula and the correct version of the formula to use. Okay, here C is equal to Q by V and F is equal to, or B is equal to F by QV. Okay, let's come to this one. An infinite number of masses of 1 kg each are placed along x-axis, okay, at this distances, okay, at plus and minus both of them. Okay, so you are supposed to tell the magnitude of the gravitational potential at x is equal to 0. Okay, so this is symmetric. Let me make it easy for you. Okay, so it's quite simple actually. So V is equal to Gm by R minus Gm by R, but here they are interested in magnitude only. So we'll add the potentials due to different masses over there, right? Gm1 by R1, Gm2 by R2. Each one is 1 kg, so Gm1 by R1, I'll write it this way, by R1 by R2 by R3, okay, and go on. Again, if you see, we have like this, right? Here we are supposed to find at x is equal to 0 the potential. We have m over here, m over here, okay, plus and minus 1, and at 2m also we have 2 meters, okay, this stands for meter. Then we have at 4 also, here also, okay. So what we'll do, we'll find the potential due to this part, okay, and multiply it by 2. Potential is a scalar, okay, it does not have any direction, so this potential and that potential will not cancel, it is a scalar. Okay, so we'll find the potential due to these, all these masses, and we'll multiply it by 2. Okay, so that is what we'll do. So potential is Gm by R. Okay, so only the R is varying, each of them has 1 kg mass, G is constant. So we can write it as 1 upon R1, R1 is 1 meter, right? Divided by 1 upon R2, 2 meters, 1 upon R3, which is 4. So you can see a GP happening over here, right? GP in the making. So Gm by M is 1, so let's forget about that. So this is a GP, infinite GP, and the sum is 2, okay? Sum is 2. Basically the first term divided by 1 minus the common ratio, which is half. So 1 divided by 1 minus half, so 1 by half, that is 2. So 2 times G. 2 times G, okay. So that is not the answer because we have to multiply it by 2. This is the potential due to this, all these masses. We have to multiply it by 2. So 4G is the correct choice over here, okay. Please keep that in mind. So that's all from these two questions. Let's move to the next question now. So question 23 and 24 over here. 23 from semiconductors now. Okay, so active state of NPN transistor is achieved at. Okay, so this is quite simple if you know the output characteristics. Okay, the transfer characteristics VO and VI. Okay, so this is the output voltage, this is the input voltage, and the graph is somewhat like this, right? So at low input voltages, it is in the cutoff state. Okay, at high input voltages it is saturated, right, in the saturation state, and here we have cutoff. Okay, and in between it is in the active state. Okay, here it is at cutoff and saturation, you can use it as a switch. Okay, but in between it is active. Okay, so at low input voltages it is in cutoff, high input voltages saturation, so neither is the correct choice over here. Okay, the when the voltage is intermediate, then only your transistor is in the active state. Okay, now let's come to this one. This one is also simple. A turntable of radius 10 meters is making 98 revolutions per in 10 seconds. Okay, now there is a boy of 60 kgs who is standing at the axis at the center of this disc, and he starts moving along a radius, and when he is 4 meters away from the center, you are supposed to tell what will be the frequency with which the find the frequency when the boy is 4 meters from the center. Okay, so what will be the frequency of rotation when boy reaches 4 meters from the center? Okay, the moment of inertia of the turntable is given as 1000 kg meter square. Okay, now again it's pretty simple, and you are supposed to use the conservation of angular momentum I1 omega 1 equals I2 omega 2. Okay, here we assume that boy moves gently and there is no external torque involved over here. Okay, and we can say I1 omega 1 equals I2 omega 2. Now omega 1 and omega 2 are directly proportional to frequencies. Omega is basically 2 pi f, right? 2 pi nu, I'll say. Okay, so I1 nu 1 is equal to I2 nu 2. Okay, so in place of omega 1 you can write 2 pi nu 1, and omega 2 you can write 2 pi nu 2. So 2 pi and 2 pi will get cancelled on both the sides, so we'll get this. Okay, now I1 is the moment of inertia initially, and the boy was standing at the center. Okay, when it's standing on the axis, there is no moment of inertia of the boy. Okay, the moment of inertia is purely due to the turntable. Okay, so we'll say it is 1000. Okay, so I1 is 1000. Moment of inertia of the boy is not considered over here, is standing at the axis. On the axis r is 0, mr square 0. Okay, so nu 1, the frequency earlier 98 revolutions 10 seconds, so 9.8, 98 by 10. Okay, so yes, 9.8 revolutions. I2 now is the moment of inertia when the boy, now finally boy reaches 4 meters from the center. Okay, so 1000 first of all of the turntable plus, okay, plus mass times r square, mass times r square. We'll treat the boy as a point object because the turntable is huge, 10 meters, right? So okay, and that into nu 2. Okay, so here we'll get 98. Okay, 98 into, I'll keep it this way, 98 into 100 divided by 1000 plus 60 into 16. 16 6 are 96, 960, 960, 1960. Okay, and here we will get nu 2. So 98 2s are 196, or 9.8 2s are 19.6. So this is 20, 25 is 100. So nu 2 is 5 hertz. So 5 hertz is the correct choice over here. Okay, that is simple. Let's move to the next question now. So question 25 and 26 over here. In 25 we are transmitting a signal. We are supposed to tell if the height of the signal is h above the earth's. Okay, so from the surface of the earth the height is h. Okay, so maybe we are releasing the signal from a tower of height h. Okay, so we are supposed to tell what is the maximum distance that this signal will transfers. Okay, or the maximum distance d is given. Okay, you are supposed to tell what will be this d proportional to what power of h is this d proportional to. Okay, so let's imagine this. There is a short derivation behind this. So here, suppose we have the tower. This is Earth. Okay, this is the radius of the Earth, and at a height h from the surface, we have the tower. From here, we release the signal. So maybe this is the maximum distance that it can travel. Okay, so from here you can connect this. So this will be again r, and this is the distance d, right? So our objective over here is to find the proportionality between d and h, right? So here you can see a nice right angle triangle. So you can write d square plus r square, Pythagoras, is equal to r plus h the whole square, right? So d square plus r square, r is equal to r square plus h square plus 2rh. That will cancel. D is equal to under root. I can take RH common. So RH common. So 2 plus h square by, I can have to h common and r. Okay, if you multiply, it will again open up to this thing. Okay, so now if you see h by r. Now h height is pretty much less than the radius. Of course, the height of the tower is pretty much less as compared to the radius of the earth, right? So this will be almost 0. So h is under root 2, sorry, d is under root 2 rh. So d is proportional to h to the power half, root of h. Okay, so option C is the correct choice over here. Okay, so now here you are given a combination of different gates. Okay, you are supposed to tell what is this entire gate equivalent to. Is it an AND gate, an OR gate, NOT gate, or none of them? Okay, so let's solve it. Actually, you can go by the trivial method, substitute 0 and 1 over here, look out for the output and match it with a particular gate. Okay, I think that will take a long. Let's do it by the Boolean formula. Okay, I also don't know a lot of Boolean algebra, but I'll do it. I'll manipulate it to sets. I'll come to that. So let's begin with A and B over here. Okay, so A, the signal is going. So here also we'll get A. So A, and here we'll get not A, right? A bar, and here the signal is B. So here also we'll have B. Now A naught and B are going in. This is AND gate. AND gate just multiplies the inputs. Okay, so this is the output. So this output will go as input over here. So A, B and A. So basically this is OR gate. So OR gate adds the two inputs, right? This and this input it will add. Now we have to say what does this stand for. A plus not A into B. Okay, now let's use the idea of sets. Basically plus means union, okay, and into means intersection. Okay, so that is what I'm going to use. So A plus, in place of plus I can use union, plus A naught. So A dash I can use A complement, union. So I'll put this in brackets, union. Okay, it's not union, dot is intersection into B. Okay, so I can open this up actually. So A union, not, no plus sign over here. Okay, plus is replaced by this. So A union A bar, intersection A union B bar, A union B, sorry. So A union A bar. So A and not A and the union of that. So if we have a set like this, okay, so A, B. So not A, first of all, A is this. Okay, not A is entire thing except A. Okay, so union of that is the universal set, right? So A and not A, so that is universal set. And intersection A union B, we'll keep that as it is. So what is the intersection between A union B and A? Now it's easy to imagine. This is A and B, this is A union B, right? And universal set is the entire thing. What is the intersection? What is the common part? Of course, A union B, right? A union B. Now you can again convert it union to plus sign. Okay, so A plus B. A plus B is the Boolean algebra for OR gate. OR gate adds the two inputs, right? So option B, OR gate, is the correct choice over here. Okay, I think that was a smart way of doing it. If you want a video on this, okay, how did I do this, do let me know in the comment section. I'll make a concept capsule on it. Okay, So for now, let's move to the next question. So question 27 and 28 over here. In 27, we have a mass of 5 grams, which is executing SHM. Okay. The amplitude of the SHM is 0.3 meters, and the time period of this SHM motion is pi by 5. Okay. You are supposed to find the maximum value of the force that can act on this block or the mass during its SHM motion. Okay, it's quite simple because acceleration max will be omega a. Okay, and when the acceleration is max, the force will be maximum. Force maximum basically will be m into a, right? M into a maximum. So a maximum is omega square a. So sorry. So omega square a. So omega you can find it by 2 pi by t. So 2 pi by t. Okay, t is, if you see, period is pi by 5, so 2 pi by 5, pi by 5. Okay, so that goes on top, and a, which is amplitude 0.3, and this is squared. 5 2s are 10, pi cancel, 10 and 10, what is that, 5 2s are 10, 10 and 10 to the power 4, or I can write it as 10 to the power 3, and 1 10 I'll multiply over here, so 3 into 10 to the power 3, that is meters per second square. Okay, so much. And finally, we'll have the force, the maximum force. It will be nothing but mass into maximum acceleration, right? Mass is 5 grams. 5 into 10 to the power minus 3 into 3, something going wrong over here. 5 is at 10, here we have 10, 10 square, that is 100, I guess. Okay, so here we made a mistake. So 5 is at 10, 10 square 100, 100, and 110 I have to multiply. Okay, so 10 I'll get over there. Okay, so here we'll have 10 or 30 basically. Okay, so 5 3s are 15, 15 and 10 to the power minus 2. Yeah, so 0.15 Newton. Yeah, so option D, 0.15 Newton is the correct choice over here. Let's get to this one. It's also simple. Okay, pulse of a normal person is 75 beats per minute. Okay, so that is the average pulse. Sometimes your heart skips a beat when you see her. Let's come back. The time period of the heart. Okay, so time period will be basically 1 by f, right? 1 by f. This is frequency, and it is in minutes. So 1 by 75, and that is in minutes. So 75 by 60. Okay, per minute. Okay, so per 60 seconds. So that will be 60 by 75, or 15 4s are 60, 15 5s are 75, 0.8. Okay, so yes, 0.8 is the correct choice over here. Okay, so let's move to the final two questions, which will be your homework questions, and you'll let me know the answers in the comment section of those questions. Okay, so question number 29 and 30 over here, these are your homework questions. You can pause the video here, take a screenshot, and do let me know the answers in the comment section. Okay, if you answer those correctly, you'll receive a heart from me. Okay, and that's all from today's video. I hope you enjoyed it. If you did enjoy it, smash that like button and consider subscribing. Means a lot to me, and I'll see you soon in the next video. Till then, keep enjoying physics.